Writing expressions of the form a cos theta plus b sine theta, where a and b are constants, as a sine or a cosine function only. So, show that 3 sine x plus 4 cos x can be expressed in the form r sine x plus alpha, where r is bigger than 0 and alpha is between 0 and 90 degrees. So what we do, r sine x plus alpha is r sine x cos alpha plus r cos x sine alpha. That's our addition formula from video 21. If we replace that with the expression 3 sine x plus 4 cos x is r sine x cos alpha and r cos x sine alpha, and compare the terms, we can see that 3 must be the same as r cos alpha and 4 must be the same as r sine alpha. So cos alpha is 3 over r, sine alpha is 4 over r, and if we draw a little triangle, we have 3, 4, and the hypotenuse is r. Pythagoras leads us to conclude that r is 5. So we could do this with either equation, but we'll just pick the first one. Therefore cos alpha is 3 over 5, inverse cos. Find the smallest value in the acceptable range, 0 to 90. So 53.1 is the smallest value. So therefore 3 sine x plus 4 cos x is 5 sine x plus 53.1 degrees. Show that you can express sine x minus root 3 cos x in the form r sine x minus alpha, where r is bigger than 0 and alpha is between 0 and pi over 2. So first up, addition formula. R sine x cos alpha minus r cos x sine alpha. Replace the expression. Compare the terms. So 1 must be the same as r cos alpha and root 3 must be the same as r sine alpha. Pythagoras to find what r is. So then once you know what r is, then it's a simple trig equation to solve. Cos alpha is a half. The first angle in the range is pi over 3. So therefore it's 2 sine x minus pi over 3. Once we've done that, we can now sketch the graph quite easily, because the graph of sine x minus root 3 cos x is the same as the graph which is 2 sine x minus pi over 3. So we kick off with sine x, then we can translate it to pi over 3 units to the right, then we make sure we label where it cuts the axis, then we times it by 2, which is a vertical stretch of scale factor 2. So we end up with our transformed graph. So whereas being able to draw sine x minus root 3 cos x straight off the bat might be tricky, once we've converted it into a sine function of its own, then we can use the transformations of graphs to draw it very easily. We also need to know the y-intercept, 2 sine minus pi over 3, or minus root 3. Express 2 cos theta plus 5 sine theta in the form r cos theta minus alpha. R is bigger than 0, alpha is between 0 and 90 degrees. Same logic, addition formula. R cos theta cos alpha plus r sine theta sine alpha. We just have to make sure we pick the right addition formula. Replace the expression, compare the terms. So 2 must be the same as r cos alpha, and 5 must be the same as r sine alpha. Again, Pythagoras to find out what r is, and then solve the corresponding trig equation. Cos alpha is 2 over root 29, inverse cos gives us 68.2, which is in the acceptable range. So we can write it as 2 cos alpha plus 5 sine theta is the same as root 29 cos theta minus 68.2. It's as simple as that, this method. We need to know the addition formulas and we need to be careful, but it's a relatively straightforward method. Once we do that, of course, we can then extend it by solving equations. So solve 2 cos theta plus 5 sine theta is equal to 3 between 0 and 360. Now we can't solve it as it stands, but if we can rewrite it in some way, we can. Now we've already shown in the previous example that it's the same as root 29 cos theta minus 68.2, so we can solve that equation instead. Make that equal to 3 between 0 and 360. It's a new range, it's theta minus 68.2, so we've got to adjust the range. So now we're looking for solutions between minus 68.2 and 291.2. Divide by root 29, inverse cos, to get one answer, 56.1. Find the other answers in our new range, which are minus 56.1. And are there any more? 303.9, that's outside our range, so we don't have to worry about that one. And then adjust it by adding on 68.2 and put them in the right order, 12.1 and 124.3 degrees. Find the maximum value of the following expression and the smallest positive value of theta at which it arises. 12 cos theta plus 5 sine theta. So r cos theta minus alpha, chosen as it gives us the same form as the expression. So r cos theta cos alpha plus r sine theta sine alpha. Do exactly the same process. Addition formula, compare the terms. So 12 is r cos alpha and 5 is r sine alpha. Pythagoras to find the length r, 13. Solve the corresponding simple equation that cos alpha is 12/13. Get the answer between 0 and 90, which is going to be 22.6. So now we can rewrite it as 13 cos theta minus 22.6. So the max value of cos theta minus 22.6 is equal to 1. So 13 times 1 is obviously 13. That's the maximum value, because it's a vertical stretch of scale factor 13. Cos peaks at 0, however it's being transformed, so it's now going to peak at 22.6, which gives us the 0. And we know it's a translation in a positive direction of 22.6 degrees. So our max is at 13 and it occurs at theta 22.6. So a sine theta plus or minus b cos theta, r sine theta plus or minus alpha. A cos theta plus b sine theta, r cos theta minus or plus alpha. Whichever ratio is at the start, change the expression into a function of that, because that is what makes solving problems easier. So if sine is first, turn it into a sine expression. If cos is first, turn it into a cos expression. Remember to get the plus and minus signs the correct way around. So pay careful attention to the order to sines.